Stationary point. Differentiation example 5. Y equals 2x cubed plus 4x squared plus c. C is an integer. Find c value when y coordinate of the maximum point is minus 260 over 27. So the clue to this question is the maximum point. When you have a function, the graph of the function could either have a maximum or minimum point. In order to find the maximum point, we always find the turning point or the stationary point. The stationary point is when the gradient equal to 0. So the gradient, when it's a straight line, horizontal line, that's when the gradient is 0. So that could be the top or the bottom. Now we're trying to determine if that's the top and that's the bottom. Now, in order to find that out, we need to find the second gradient. That means we have to differentiate that gradient again. And if that gradient is now positive, we call it the 2y, the x squared. That's the second derivative. This is the first derivative. That's the second derivative. So that's its first gradient. And we differentiate the gradient again. We get a second gradient. And if that's greater than 0, that means positive, that would be the minimum. Because you go from 0 gradient to positive gradient. If the gradient going from 0 and the second derivative, the second gradient is negative, then you're going from 0 to negative. So that would be maximum. So that's maximum. And this is minimum. So that's what we're looking for. The 2y, the x squared, will be less than 0. That point, if it's maximum, the y value will be this. That's what this is saying. The y coordinate of the maximum point is that. And we need to find the x value. To find that x value, we need to differentiate and set it to 0. That's called the stationary point. So this is the stationary point at the stationary point. That implies the y dx equal to 0. So we're trying to determine whether it is a maximum or minimum. We've got the function y equals 2x cubed plus 4x squared plus c. We know that c can be a negative number, a positive number, or 0. Whenever we're doing differentiation, we must have our function in the form of x to the power of n. Then we can apply the y dx. So the y, the x, will be n x to the power n minus 1. We could also apply the second derivative, the 2y, the x squared, and that will be n into bracket n minus 1 x to the power n minus 2. Or we can just differentiate that again. But to have this function look like that, this has got 3 terms, 1, 2, 3. So we differentiate term by term. In order to do that, we have to make sure this function looks like that. But that doesn't look like that. The c doesn't have x variable. Actually, it has x variable. Y equals 2x cubed plus 4x squared plus c x to the power 0. X to the power 0 equals 1. 1 times c will be c. Now each term looks like that. So now we can apply the y dx. So at the stationary point or the turning point, the y, the x will be equal to 0. So now let's find the y dx. The y dx is 3 times 2 equals 6x, 3 minus 1 to power 2, plus 2 times 4, 8x, 2 minus 1 to power 1, plus 0 times c, that'll be 0. So now we need to set the y dx to 0. That means 6x squared plus 8x equal to 0. There's a common factor here, is 2x. 2x, open bracket, 3x plus 4 equal to 0. Now, at this point, I have to set 2x to 0 and 3x plus 4 to 0. Set that to 0 and set that to 0. So 2x equal to 0 is x equal to 0. So divide both sides by 2. Also, 3x plus 4 equal to 0. Therefore, 3x equals minus 4. X equals minus 4 over 3. So now we've got the two x values. One of them is maximum, and the other will be minimum. To determine which is maximum and which is minimum, we need to find the second derivative. So the 2y, the x squared, will be, if you differentiate that again, 2 times 6 is 12x, 2 minus 1 is 1, plus 1 times 8 will be 8x, 1 minus 1 will be to power 0, and that will be 12x plus 8, because x to power 0 is 1. 1 times 8 is 8. Now we need to find the value of the 2y, the x squared. One of them is going to be positive and the other most likely to be negative, which would then tell us whether it's minimum or maximum. So the 2y, the x squared, when x equal to 0, will be equal to 12, 0, plus 8, and that will be 12 times 0 is 0, plus 8, so that will be 8. It's positive, it's greater than 0, that's minimum. Now we need to find when x equals minus 4 over 3, the 2y, the x squared, when x equals minus 4 over 3, that should be 12 into bracket minus 4 over 3 plus 8, and that will be, well, 12 divided by 3 is 4. 4 times minus 4 is minus 16. Minus 16 plus 8 is minus 8. And that is negative, less than 0, so that is maximum. So this is maximum. So what I meant is, going back to the question, when y coordinate of the maximum point is minus 260 over 27. This is the x value of the maximum point. So the x value, so for the maximum point, this one here, the x value is minus 4 over 3, and the y value is minus 260 over 27. And we're told to find the c value. But we know that y equals from the equation 2x cubed plus 4x squared plus c. Therefore, c will be y minus 2x cubed minus 4x squared. That will be minus 260 over 27 minus 2 into bracket minus 4 over 3 cube minus 4 into bracket minus 4 over 3 squared. So c equals, putting that into calculator, you get c equals minus 12. So therefore, the original equation will then be y equals 2x cubed plus 4x squared minus 12. Just to show how to find the value of c using the calculator, open bracket, fraction, minus 260, arrow down, over 27, arrow to the side, close the bracket. That's the first one there. The second one is minus 2, open bracket, fraction, minus 4, arrow down, 3, arrow to the side, close bracket, raised to power 3, arrow to the side, minus 4, open bracket, fraction, minus 4, arrow down, 3, arrow to the side, close bracket, raised to power 2, and then press equals. We get minus 12.